Now we will talk about the energy of the simple harmonic motion or the simple harmonic oscillator. Okay. We have learned before that the restoring force, that is the force from the spring, okay, you have, if you attach an object to the spring, and the spring will exert the restoring force to the object, and Fs equal to minus kx, and we know that this force, we have learned before that this force is a conservative force. Okay. When we know that a force is a conservative, we can define the potential energy. Okay, and we have talked about this before, that the potential energy the change of the potential energy in the case of the restoring force from the spring is equal to 1/2 of k x2 square minus x1 square. It means that if the object moves from the position x1 to x2, this is a change of the potential energy. Okay. And we also know that the kinetic energy, the change of the kinetic energy is equal to the 1/2 of m v2 square minus v1 square. So since the restoring force is a conservative force, and in the case of the simple harmonic motion, we don't have other forces. We don't have friction, we don't have other kind of force, just the force from the spring. So what we have from the principle of conservation of energy, we have that delta U plus delta K must equal to 0, or we may write 1/2 of mv1 square plus 1/2 of k x1 square equal to 1/2 of mv2 square plus 1/2 of k2 square. And from this we energy of the motion. The total energy of the motion E is equal to the 1/2 of mv square plus 1/2 of kx square, which must be a constant. Okay. So this is a conservation of energy for the simple harmonic motion. The total energy is equal to the 1/2 of mv square plus 1/2 of kx square, which must be equal to constant. Okay. Now, if we go into the detail, since we know the expression of x and v, so we can write down the energy in terms of the t. Okay. We have that xt is equal to a sine omega t plus 3. Okay. And we have v t is equal to omega a cos omega t plus 3. So the energy is equal to the 1/2 of mv square plus 1/2 of kx square, which equal to the 1/2 of m omega square a square cos square of omega t plus 3 plus 1/2 of k a square sine square of omega t plus 3. Okay. But from the definition, we have that omega square is equal to k over m. So we have that E is equal, if we put k over m into this omega square, so we have that E is equal to 1/2 of k a square of times sine square of omega t plus 3 plus cos square of omega t plus 3. And we know from trigonometry that sine square plus cos square is equal to 1. So have that the total energy is equal to the 1 over 2 of 1 over 2 times Ka squared, which is a constant in time with amplitude B, because we say that the resultant force is a conservative force, so the total energy is not changed in time. So in this expression, we can write down the total energy in terms of the amplitude of the oscillation. You can see that the energy is is depend on the amplitude square. Okay, and a constant in time.